So acid plus metal oxide, this will result in a formation of salt and water. So if I say magnesium oxide react with sulfuric acid, A part, write a word equation for this reaction. So what will be the word equation? Magnesium oxide is reacting with sulfuric acid. So word equation will be magnesium oxide plus sulfuric acid what will be the result for this if we are completing a word equation? Magnesium oxide plus sulfuric acid. What is the result here? This will form magnesium sulfate plus water. That's the first thing. Second, if I say write equation for this, even if they say write equation, it means a symbolic equation. So if you want to write equation, magnesium oxide, this we already discussed in the previous session. Magnesium oxide is MgO, H2SO4, which is sulfuric acid. This will result in a formation of magnesium sulfate, which is MgSO4 plus water H2O. So magnesium oxide plus sulfuric acid gives magnesium sulfate plus water. The state symbols, magnesium oxide is solid, sulfuric acid is aqueous, magnesium sulfate is aqueous, water is liquid. And if you want to write an ionic equation, so for writing an ionic equation, we cancel out the common ions. So sulfate ions are spectator or common ion. So the ionic equation will be magnesium oxide plus 2 hydrogen ions from sulfuric acid result in a formation of magnesium ion plus water molecules. This is ionic. And if the question is how you'll obtain salt magnesium sulfate so how we'll obtain this salt magnesium sulfate by this reaction? So first what we will do, what are the steps? Number one, we will warm sulfuric acid. So first we warm sulfuric acid, then we will add magnesium oxide or metal oxide until no more dissolve. Then we will filter to remove unreacted metal oxide and then use either one of them. You don't have to mention both. Use crystallization as the best technique to obtain a salt from solution rather than evaporation, because evaporation required a lot of heat energy to remove all of the liquid. So use crystallization to obtain salt from solution. If this question is of 6 marks, then you have to explain crystallization in detail, like how you do in what you do in crystallization. But it's a 4 marks, then you can just mention or use the technique crystallization to obtain the salt from solution. So depending on the marks, so you have to be sure and check the marks before writing this experiment. If it's a 4 marks, then these are the points. But if it's of 6 marks, then you have to explain crystallization, as we discussed already, heat and concentrate the solution, then cool down the solution and filter, and then dry. This is a crystallization process. Is it clear? The second method, how to obtain a salt when acid is reacting with metal oxide. Take the screenshot of this. The difference between aqueous and liquid state, aqueous means when something dissolve in water. Inside water we call aqueous. Like example, HCl, hydrogen chloride, is a gas at room temperature. Okay, so we write state symbol HCl, gas. But if this HCl is added to water, like you have a container and you add this gas to water, so then what it become, what we call that substance, we will call this is also HCl, but it is aqueous HCl. Aqueous HCl means that HCl is mixed or dissolved in water. So when substance dissolve in water, we call aqueous. When substance having a state like liquid, gas, so we just write L. The third reaction, when acid, metal carbonates plus acid, this will result in a formation of 3 products. One is the salt, another one is water, and the third one is carbon dioxide. So acid plus metal carbonate result in a formation of salt, water, and carbon dioxide. Metal carbonates, generally metal carbonate, these solids. Acids will be aqueous. Salt depends on which salt is produced. It can be aqueous or it can be solid depending on the salt. Water is liquid and carbon dioxide is a gas. What will be the observation when this reaction will occur? What you will see? What are the observations when this reaction will occur? You are adding a metal carbonate to acid. Yeah, bubbles, fizz, effervescence, and what else? The solid dissolve. So metal carbonate size will decrease as it is reacting, or you can mention dissolve. And the second is you will observe bubbles or fizz. You can mention when it's a rapid formation of a bubble, you can use the term fizz, or you can also say effervescence. So when we add metal carbonate to acid, we'll observe that bubbles are coming out and the solid size is decreasing. Now writing an equation, word equation. So if I want to write a word equation, if I say I have calcium carbonate plus hydrochloric acid. What will be the product when calcium? So calcium chloride will be there, because if it's a hydrochloric acid, it will form a chloride salt. So calcium chloride plus water plus carbon dioxide. So metal carbonate plus acid, this will result in a formation of salt, water, and carbon dioxide. This is a word equation. Metal carbonate is in a solid state, hydrochloric acid aqueous, gives calcium chloride plus water plus carbon dioxide. This is a word equation. Now, if I want to write a symbolic equation, calcium carbonate. So you have to work out the formula. Calcium carbonate. Calcium is group 2, so it's +2. And carbonate valency is -2. When two valencies, you will first simplify. It's 1:1. So it will be calcium carbonate formula will be CaCO3. Hydrochloric acid is it is HCl. This result in a formation of calcium chloride. So calcium is +2, chlorine is group 7, so it is -1. When you cross multiply, calcium chloride will be CaCl2 plus water, that's H2O, and carbon dioxide is CO2. Yes, that's right. CaCO3 plus HCl gives CaCl2 plus H2O plus CO2. This is the first part. We complete the equation as the first thing. The second part is balancing the equation. So I start with oxygen. How many oxygen on my right hand side? 1 plus 2, 3. How many oxygen on my left hand side? 3. So oxygen is balanced. Followed by hydrogen. Hydrogen on my right hand side 2, on my left hand side 1. So to balance hydrogen, what I will do? I will put 2. So when I put 2, hydrogen is also balanced. What about other elements? When I balance hydrogen, you can see other elements are already balanced. 2 chloride here on the left, 2 chloride on the right. 1 carbon, 1 carbon, 1 calcium, 1 calcium. So this equation is balanced in terms of all the elements. Is it clear? This equation is balanced in terms of all the elements. Then write the state symbols. Metal carbonate, this is solid. Hydrochloric acid, aqueous. Calcium chloride, most chlorides are soluble except silver, mercury, and lead. So is it soluble or insoluble? Or aqueous or... So most chlorides are soluble except silver, mercury, and lead. So it will be aqueous. Water is in a liquid state and carbon dioxide is a gas. Now to write an ionic equation. So if we want to write an ionic equation, first to write an ionic equation, we should have a balanced symbolic equation. So first we will use the balanced symbolic equation in which we have calcium carbonate was reacting with 2 hydrochloric acid molecules, result in a formation of calcium chloride plus water plus carbon dioxide. Calcium carbonate is solid, hydrochloric acid is aqueous. This was aqueous as well. This is liquid and gas. You will highlight the aqueous substance and cancel the common ion in aqueous. Any common ion is there in aqueous? Which ion is common in aqueous substance? So chloride ions are common. So we will cancel this chlorine with another chlorine. So what we are left with, that is the ionic equation, like CaCO3 plus hydrogen ions result in a formation of calcium ion plus water plus carbon dioxide. Is it clear? The ionic equation. So this is your ionic equation. Take the screenshot. I will give another example. Now, example, if we have, because we are discussing an equation in which the metal carbonate is reacting with acid. That's result in a formation of salt, water, and carbon dioxide. Example, you have lead carbonate. Reacted with sulfuric acid. Lead 2 carbonate, because it's a transition element, that's why. Valency is also written, like it may have variable charge. So lead 2 carbonate, 2 is just showing the valency or the charge of lead, plus sulfuric acid. What will be the result, the product? What will be the product when lead carbonate is reacting with sulfuric acid? So this will produce, it's a sulfuric acid, so sulfate should be there. Yeah, so lead 2 sulfate, your lead sulfate, even you can mention lead sulfate plus carbon dioxide plus water. This is a word equation. You want to write a symbolic equation for this. So lead 2 carbonate, what will the formula for lead 2 carbonate if we work out? So lead, it's plus 2 and carbonate is minus 2. So when two valencies are same, you simplify, cross multiply. Lead 2 carbonate will be PbCO3. So that's PbCO3, lead 2 carbonate. Reacted with sulfuric acid, which is H2SO4. When they react with each other, this will result in a formation of lead sulfate, or basically lead 2 sulfate. So lead is plus 2 and sulfate is minus 2, SO4. So when you cross multiply, simplify and cross multiply, it will be PbSO4. Water is H2O, and carbon dioxide is a gas. When we write the state symbol solid, aqueous, lead sulfate, most sulfates are soluble except calcium, barium, and lead. So in this case, the salt which is formed is a solid. So most of the examples which we did, we are getting a aqueous salt, but in this example, we have a solid form. This will be liquid and this will be gas. Now, if I want to write an ionic equation for this reaction, I cannot write ionic equation separately. Reason? Because there's only one aqueous substance. There's only one aqueous substance H in H2SO4. There's no other aqueous substance. So the ions will not cancel out each other. Why it is H2SO4? Why not HSO4? Because hydrogen valency is +1 and sulfate valency is -2. So when you cross multiply, you will find it is H2SO4, not HSO4. Because the valency of the sulfate is -2. So for this equation, we don't have to write an ionic equation because it does not make an ionic equation. There's no change in the ions. So it will be same as symbolic. When you have two aqueous substance, then you have a spectator ion, but for this one, you don't have an ionic equation. Is it clear? Means the symbolic equation is same as the ionic equation. You have to learn these valencies. If you remember, there was one table. I told you to memorize the valency. So carbonate valency is -2. How carbonate valency is -2? Because one oxygen is -1. So there are 3 oxygens. So total is -6. And carbon belongs to group 4. If the right hand side element is having a negative valency, the left hand side should have a positive valency. So when you solve +4 and -6, you will find that carbonate is having -2. But you don't have to learn this part. You don't have to go in detail of this part. In O levels, it's better you learn the valency for the molecular ions such as nitrate, it is -1, sulfate, it is -2, carbonate, it is -2 as well. Better learn these valencies. So directly you can work out the formula. But there's a rule how they get these valencies. There's a way as well. So metal carbonate react with acid. This will result in a formation of salt, water, and carbon dioxide. How to obtain a salt? From this technique, if we have metal plus metal carbonate basically. So how to obtain a salt by this method? Soluble salt. Because if it is producing insoluble salt, then we cannot use this technique. So how to obtain a soluble salt by this method? So first what we will do, carbonates normally react at room temperature, so we don't have to warm the acid here. So we will fill the beaker with acid by help of measuring cylinder or pipette or burette. Then we will add metal carbonate until no more bubbles or no more solid dissolve. Then we will filter to remove unreacted metal carbonate, and then we will use either crystallization or evaporation to obtain salt by of from solution. So you can see a similar method is used here. If you want to obtain a salt by this method, so we will fill the beaker with acid by the help of measuring cylinder or a pipette or a burette. So we take a container and we fill this container by the help of measuring cylinder or pipette or burette. So with acid here, specific volume like 10 cm cube or 15 cm cube. Then we take a spatula and using a spatula, we transfer this metal carbonate. The moment we add metal carbonate to this acid, it will result in a formation of carbon dioxide, salt and water. So we'll observe bubbles. We will add this metal carbonate until no more metal carbonate react or no more solid dissolve. So we'll left with unreacted metal carbonate. So we are left with unreacted metal carbonate, and this acid will no more there because acid is completely reacted and it will turn into salt solution. If it's a soluble salt, then it will turn into salt solution. And then we'll filter to remove this unreacted metal carbonate, and then we will use either crystallization or evaporation to obtain the salt from this solution. Is this clear, the method? Take the screenshot. Then the last reaction is when alkali or metal hydroxide plus acid. This will result in a formation of salt plus water. Metal hydroxides, if metal hydroxide is soluble in water, you can also say alkali. So acid plus alkali also gives salt and water. Acid plus metal hydroxide gives salt and water. And this reaction is known as neutralization. Because water is a neutral product, so it results in a like acid and alkali cancel out the properties of each other. They neutralize each other. So that's why we call this reaction as neutralization. So metal hydroxide plus acid, this result in a formation of salt and water. So any metal hydroxide, like example, if you have sodium hydroxide plus hydrochloric acid. So sodium hydroxide plus hydrochloric acid, what will be the result? Sodium hydroxide plus hydrochloric acid, what will be the result? If it's a hydrochloric acid, it will form chloride salt, so it will form sodium chloride. So one of the product will be sodium chloride and the second product will be water. Chloride salts give hydrochloric acid gives chloride salt, sulfuric acid gives sulfate salts, and nitric acid gives nitrate salts. This is a word equation. But if you want to write a symbolic equation for this, so sodium hydroxide formula is NaOH. How you work out? Sodium is group 1, so it's +1, and hydroxide is OH, so it's -1. So the sodium hydroxide formula will be NaOH. Plus HCl acid, so it's hydrochloric acid. This will result in a formation of sodium chloride. So sodium chloride is NaCl plus water is H2O. Then the state symbols. What is the state of alkalis? If it is soluble, like if we say specifically alkali, it means it will be aqueous. Aqueous means mixed in water. Acids are also aqueous. Most chlorides are soluble except silver, mercury, and lead. So what is this state of sodium chloride? That will be aqueous. And what is the state of water? That is liquid. Now to write an ionic equation, sodium hydroxide, which is NaOH, plus HCl gives NaCl plus H2O. So this will be aqueous, this will be aqueous, this is aqueous, and water liquid. So we highlight the aqueous substance. So what are the aqueous substances here? Sodium hydroxide is aqueous, hydrochloric acid is aqueous, and sodium chloride is also aqueous. So we have 3 aqueous substances here. Now how to complete this? We will cancel out the common ion in aqueous substance. So chloride ion is common. We cancel out chloride ion. And sodium ion is also common, so we cancel out the, so here we have 2 spectator ions, sodium ion and chloride ion. So we cancel out sodium ions, we cancel out chloride ions. So what we are left with, that will be the ionic equation. So what we are left with, hydroxide ion, which is aqueous, and we are left with hydrogen ion. And this result in a formation of H2O. Is it clear? So this is the ionic equation. OH plus H gives H2O. The spectator ion, the sodium ion is a spectator ion, chloride ion is a spectator ion. That's why we cancel both of them. And what we are left with is known as a ionic equation. So when acid react with alkali, any kind of alkali react with acid, you will always find this will be the ionic equation, always. I'll give another example. But you will find that whenever acid is reacting with alkali, the ionic equation is always same. OH from alkali react with H from acid. So OH from acid, because in ionic equation, we should write the ions for the substance in aqueous. So OH ions are -1, that's why we write -1. And H ions are +1, so we write H plus, will give H2O. So ionic equation is always same for all acid-alkali reactions. Any kind of acid react with an alkali, the ionic equation will be same, no difference. So another example, if we have potassium hydroxide reacted with sulfuric acid, I'm because of shortage of the time, I'm just completing an equation. So it will give potassium sulfate, salt, plus water H2O. Here, take the screenshot. So alkali is aqueous, acid aqueous, this acid salt is aqueous. Most sulfates are soluble except calcium, barium, and lead. Water is liquid. This equation should be balanced, so I put 2 here. So if I want to write ionic equation, I'll cancel out the common ions. So what are the common ions? Potassium ion. So I cancel potassium ion in aqueous substance, and I cancel sulfate ion. So what I'm left with? I'm left with 2 hydroxide ions, and I'm left with 2 hydrogen ions, and this will result in a formation of 2 water molecules. Or because 2 is common here, so I can write a simplest ratio. I can have hydroxide ion. This is correct. This is no difference. Plus hydrogen ion will give H2O. Is it clear? The idea that both equations are correct, you can write in a simplest one. So even without my point is, without using the idea like cancelling out the common ion, if I know acid is reacting with an alkali, directly I can write the ionic equation that OH plus H will give H2O. And you can see why we call neutralization, because hydrogen ion from the acid is reacting with hydroxide of an alkali, and they cancel out each other. As they cancel out each other, they result in a formation of water molecule, which is a neutral product. Is it clear?